Trustee is part of the CNCF Confidential Containers project, but it is a fairly loosely coupled service or collection of services. So it might be of independent use outside of Coco, but I wanted to kind of give a little bit of context there. And I have asked my friend and colleague, Ding Ma, to come in and present because in looking at the IDC report on the key adoption hurdles, it kind of seemed like attestation was a pretty big thing on there. And this trustee system helps, or rather, this trustee system provides a lot of functionality there. And so I am going to stop sharing so that I can turn the show over to Ding. Keith, you wanted
Before
to.
you hand it over, just as a newly coming back to the TAC, the slide deck you're presenting, for slides like that, it'd be really useful to be clicking the links. Where can we discover that before the meeting or during the meeting? Is that somewhere we can find?
Yeah, sorry. Usually I try to drop things into chat when I do have the links. Probably next year we'll do a better job of circulating the link to the slides beforehand. I will admit that a lot of times these slides are prepared in the moments before.
Sure. No, I understand that. One thing we use slides extensively at Google, as you might guess. The having a drive folder where those things exist might make it so you don't have to actively push them and people can go pull them.
Yeah, that's great. And so maybe, Renu, one thing that we can start doing in 2026 is when you prepare that first deck for us, you can drop the link for it into the TAC channel, and we'll just assume until otherwise that people won't abuse that edit capability.
Makes sense, definitely.
Okay, so returning to what we're about to do with Trustee, Ding, feel free to share as you're able there. Ding is from Alibaba Cloud. He's a senior development engineer. He works on confidential computing and software supply chain security, and he's one of the main developers behind Trustee. I know Ding from the Coco community, but I've never met him in person. I have slightly suspected that he might just be an advanced AI. I don't think he sleeps. I just see code and PR reviews. So good chance he is a bot, but we'll hear his text-to-speech rendition today then, if that's the case.
Oh yeah, thanks, Dan. So can you see my screen?
Yes.
Yeah, great. So, okay, let me start. So, hello everyone. I'm Ding from Computational Containers community, and now I'm working for Alibaba Cloud. So, first of all, much thanks to them for inviting me to share our work with you today. It is also really nice to see many leading contributors in computational computing, and very glad to have a chance to do the presentation about the Trustee. So Trustee is a general purpose attestation verifier and a broker for relying party services. So what I want to focus on is how Trustee can act as a common attestation and key broker layer that sits alongside existing CCC projects and vendor services. And we hope that people will know more about it and contributing to it and personally standardize its protocol. So let me start. And this is a motivation. And in computational computing, we all know attestation is essential, but in practice, attestation is a hurdle. And this slide shows the survey result from CCC folks about the key challenges or risks in adopting computational computing. And if you look at the top bar, the number one concern for more than 80% of respondents is validating attestation chains of trust. So the thing people worry about most is not just that my T exists, but also can actually validate the full attestation chain end to end in a way I understand and trust. So right below that, you can see several related challenges that many of us will recognize. The first is still seen as an initial technology with limited proof points. and there's a lake of skilled personnel who really understand all the details of attestation, TEs, and policy. And there are inconsistent approaches from public cloud providers, which creates a real risk of vendor lock-in. And there's a lack of standardization, especially in how you actually consume attestation results. And further down, you see concerns around using key lifecycle management in a confidential computing context. So taken together, this chart basically says attestation, standardization, and key management are right at the center of people's concerns. And Trustee is aiming exactly at this intersection. And first, to make attestation validation more uniform, to reduce the inconsistencies across clouds and TEs, and provide a standard way to plug attestation into K and secret lifecycle management. And let's see. So the question for us is, what would it take to address this in a way that works across vendors and clouds? That's what Trustee is trying to do. And on the left, you can see a few key properties that Trustee have. The first is Trustee provides a common attestation abstraction and protocol. Instead, every project talking to every cloud-specific verifier in a different way. Workloads can talk to Trustee in a uniform way. And it also collaborates with CCC projects like Verizon and VRTE. And we don't replace those verifiers, we consume them and turn their results into a common format that policies can use. And the Trustee can support vendor verifiers and even non-CC usages like the TPM platforms. So you can mix TEs from different vendors and still have a single broker layer, and the same protocol can also serve non-TE workloads where you still want strong policy before releasing keys. And it may help fulfill CCC or the WIMS workload identity goals by mapping evidence and measurements into a stable workload identities, which I will come back to later. And finally, it is customer driven. And many of these capabilities came directly from people who are feeling the pain you see quantified in the chart. And before I go deeper into Trustee itself, I want to briefly mention the community and representing here confidential containers. And the confidential containers was accepted into CNCF as a sandbox project in March 2022. And our focus is very much on cloud native use cases, is to running containers inside TEs, is to integrate with Kubernetes and the broader cloud native ecosystem, and make confidential computing consumable for large-scale workloads. And Trustee actually originated from the context. As we tried to run containers confidentially, we quickly hit the attestation and key management hurdles you saw in the survey. And we needed a way to standardize attestation flows and key broking across different clouds and TEs. So Trustee started as an effort inside the confidential containers ecosystem, and then grow into a more general project with a broader set of adopters. And let's see the Trustee architecture. And this on the left, we have a confidential VM, obviously a CVM with a attestation agent running inside it. This agent is responsible for collecting evidence from the TE and sending it out when the workload needs to access a sensitive resource. And in the middle is a key broker service, obviously the KBS. And this is a central piece that every workload talks to. On top of it, you see resource policies. And these policies describe which workloads are allowed to access which resources under which conditions. On the right, you can see the attestation service, and we usually call it AS. And this is where the actual verification of evidence happens. The AS checks the endorsements of the evidence, and it also provides fine-grained check against the evidence fields driven by attestation policies. The attestation policy defines what the field should be like, and it's supposed to query reference values from the reference value provider service at runtime. The reference value provider service we usually see shorted as RVPS supplies the reference values to the ES. And finally, at the bottom, you can see the KMS. The KMS is one example of the relying party that actually holds the keys or other sensitive materials that the workloads want to use. So structurally, Trustee gives us a AS that knows how to verify evidence using reference values and attestation policies, and a KBS that makes policy decisions and talk to reliant parties like KMS, and a clean separation between attestation logic and resource access logic. And we bring some more boxes into the picture, and let's see end-to-end flow and how Trustee interacts with other services. So the first one, the CVM wants to use a resource, for example, a key, and the attestation agent inside the CVM sends the attestation evidence to the key broker service. And the KBS doesn't try to verify this evidence itself. Instead, it forwards the evidence to the attestation service on the right. And the attestation service consults the vendor-specific services to verify the endorsement. And it also consults attestation policies about how to interpret this evidence and what the field should be like. And it also consults the reference value provider service and about the reference values. And using those, it verifies the evidence and produces an attestation result. The attestation result is expressed in formats like EAR, obviously the AR for SI. That attestation result is sent back to the key broker service. The KBS combines this result with its resource policies to decide whether the requesting workload is trusted enough to get the resource it is asking for. This is a whole end-to-end flow. And this picture shows the
real quick, if you don't mind stepping back one slide.
Okay.
So I know this is something that I think I knew the answer to at some point, but I'm having a hard time spinning at my brain this morning. So with Trustee, is the key broker service kind of fundamental to the mission of Trustee, or could you use this attestation service directly from the attestation agent? Or more directly, could you be getting back the attestation result, the EAR token, without involving the key broker, if that's what your use case desired?
Yes, we can.
Okay, great.
I think maybe one other clarification is that name key broker service is sort of historical, because the first use case that was there for Cocoa was encrypted containers, and so you absolutely needed a key to go decrypt the container image. Over time, this is now a general purpose resource broker, and so it stands as a sort of facade or something in front of other services.
Thanks.
Okay.
Okay, so let's go to this slide. And this is a REST reminder. And I think we are all familiar with this model. So what I want to see is that Trustee is intentionally aligned with the REST concepts. And we are not inventing a new conceptual model. We are implementing REST in a way that's convenient for cloud native workloads. So this page shows how the Trustee architecture maps onto REST. And we can see the attestation agent in the CVM is a attester, and the attestation service acts as a verifier. The key broker service acts as a relying party, and the reference value provider service supplies the reference values like supplies the reference values. And we have explicit attestation policies and resource policies. So if you think in REST terms, trustee is essentially a reliant party plus verifier plus reference value provider packaged as a reusable service with a standard way for workloads to talk to it. And let's recap the architecture of Trustee, and we will move the boxes on the next page. So, okay, we move some boxes. Let's talk about the deployment versatility. And this diagram shows a basic deployment of Trustee, and we can see it includes AA, KBS, AS, and RVPS together with policies and KMS. And let's add some more boxes into this page. And if we want to introduce some third-party services to play together on the stage, the diagram can be like this. There are a few key points. The first one is non-CC workloads can still use the KBS protocol to access the resources as long as they meet the policies. So the same broker can serve both CC and non-CC workloads using attestation where available and other claims when needed. And the point two is Trustee can broker resource accessed by URI. That might include Kubernetes-based secrets encrypted in etcd or other URI addressable resources. And the point three is Trustee can directly call third-party attestation services, for example, ITA. The point four is Trustee can call third-party verifier to verify specific TE evidence, for example, NRAS for NVIDIA, and Verizon for ARM-CCE, and others. This is where the collaboration with CCC rarely shows up. Trustee leverages Verizon's verification capabilities by calling it as a service. And this design can let us integrate with Verizon and other verifiers rather than replace them, and provide a common consumption layer for reliant parties and workloads. So let's see the next page.
I think there's a question for Mark on the call. I don't know if we'll take it now.
Yeah, and hang on just a sec, Mark.
If you don't mind, if you're going to go into it later, then I'll wait. But so you sort of the key concept here is a resource or a key, right? So you can basically go to a key broker service and get back a resource or a key. I do not understand. You also mentioned in the very beginning that you're going to somehow align this with Whimsy, and under Whimsy, what you request is a credential, right? So it's a little bit unclear to me how you make it Whimsy compatible. Have you actually prototyped this, investigated this?
So we've got that a few slides ahead.
Okay, now wait.
And then, Keith, to your earlier question, I don't know if this kind of helps illustrate the utility of the key broker service a little bit better, but any workload like a Cocoa container that's configured to work with the key broker service, if you decide that you want to use ITA instead of the trustee attestation service, you don't have to make any changes on the left hand of the diagram, or you get a new verifier in place for a new architecture that all just goes on the back end and you don't have to affect the workload. Sort of similarly with those different resource providers that depend on this, like etcd there. So you can have that configured with your normal Kubernetes distribution, or what we'll get to in a few slides with Mark's question about getting a workload ID. Benny?
Yeah, thank you. I also have a question about etcd because you just mentioned that here. Because how could the key broker service, or where is the key broker service deployed when it accesses it? Because assuming you just deploy the key broker service in your regular Kubernetes cluster, that's not good, right? Because it has to be protected. It's very sensitive and so on.
Yeah, that's a great question, and I think we could use some diagrams for that. But one deployment model you might choose is that your container infrastructure is in a CSP, and you operate the key broker service on-prem in your own data center. So it
And
is
it still could connect to etcd to get the secrets out?
right. So you would need the right network relay in place to be able to do that. But the idea is that the resources. So one specific use case is you can use Kubernetes secrets in etcd. So normally those are effectively clear text. And we don't want the Kubernetes administrator to be able to read those. So instead we put them in an encrypted form in etcd. And then the KBS helps deliver a key so that you can decrypt that locally within the container.
Okay, thank you.
Yeah. Okay. So, sorry. So I can't see the raising hand. So please interrupt me and please interrupt me at any time if you have any questions. Thank you. Okay, let's go ahead. Let's see where we are. And we just finished the deployment versatility, and let's see we will get to the workload identity topic. So let's see the architecture again, and we will add some more boxes onto the page. And I want to connect Trustee to a workload identity discussion in the CCC workload identity SIG. And the core problem we are looking at is in the confidential computing. How do we give workloads a stable identity? And when what we actually trust are very low-level measurements like container hashes and T registers. And on this slide, I'm focusing on what we already have to work with. If you look on the left, inside the CVM, we have a container running and a attestation agent. And that agent can see and report a container hash. The hash is very strong, but also very brittle identifier. And we can also include host data for SMP, configuration IDs for TDX, and personalization data for ARM-CCA in the attestation. Those are shown along the bottom. And on the right, we still have our attestation service and RVPS, which verify the evidence and produce an attestation result driven by attestation policies. And in the middle, the KBS now has the extra function, claims mapper policy. And the idea is that KBS can consume attestation result from the attestation service, and plus all those low-level claims, container hash, host data, config IDs, and then apply a claim mapper policy to turn that into a higher level workload identity. And that workload identity could then be handled to something like a Spire server and expressed as a SVID or another long-lived identity. And let's walk through an end-to-end example of how this could work in practice. And step first, we start by creating a CVM with an expected container hash or some host data or config ID or personalization, and to initialize the CVM. And step two, inside the CVM, the agent enforces the container hash in the host data, config ID, personalization matches the running container. For Coco, the agent is named cut agent. And step three, when the CVM attests to the KBS, the evidence includes host data like AB123 and runtime measurements like RTMR2 equals to AB123. And step four, the attestation service verifies the evidence using its policies and reference values from RVPS and produce a attestation result we support to add some extra information along with the attestation result extracted from the whole evidence. And this extra information is called validated identifiers. For example, the container hash, the init data. Oh, the init data is the abstraction for the host data for SMP, config ID for TDX, and personalization field for CCA. So then the step 5, the attestation result and the validated identifier flow into KBS where the claims mapper policy runs. And that policy maps a container hash plus init data plus whatever other claims that we care about to a specific workload identity. Essentially, that means this is a service X and obviously this is a workload Y. And the last step, the workload identity is certified, for example, as a SVID for the workload. So downstream systems don't have to deal with the RTMRs or the attestations or the container hash. They just see a normal SPIFFE ID or similar identifier. And this identity represents the workload. So this page, let's talk about the KBS protocol. And this is the attestation protocol that Trustee uses. And this protocol has two phases. And the first one is authenticate. The client and the KBS perform what we call an RCAR handshake. It's basically a challenge response style protocol. And at the end of this handshake, the client gets either an attestation token or a session cookie. This token or cookie encapsulates the attestation result and the trust decision at that point in time. And the stage 2 is request a resource. The client then presents the token or cookie. It requests a resource by URI. The KBS checks the token, evaluates the resource policies, and if everything passes, it returns the resource. So this design is first TE agnostic. The protocol doesn't hardcode Intel or AMD or ARM in the protocol, and it is cloud agnostic. Different clouds can plug their own verifier services behind the KBS, and it's also usable by non-CC workloads that can authenticate in other ways. And this picture shows a detailed process of the protocol, and I think we are not going to dive too deep into the cryptography design, but on the left we can see the RCAR messages body format, and it provides an anti-reply attack security, and on the right it is a resource access process, and all the resource get from the KBS will be encrypted in GW format with the TE pub key inside of the attester. And finally, a quick look at what's coming next. And today, Trustee is typically deployed as a regular service, often in a secure environment, but not necessarily in a TE of its own. We are working towards as a deployment mode where Trustee itself runs inside a TE or enclave, establishing its own root of trust. This would allow stronger security for the KBS and the attestation service. And stronger guarantees to clients that the broker itself hasn't been tampered with. This is another area where we're very interested in is how should a trusted broker service be attested? How should the trustee in TE communicate its own trustworthiness to clients? And to wrap up, Trustee provides a general purpose attestation verifier and broker for reliant party services. and it already integrates with Verizon for MCC, and we can call other verified services like IT and NRAS. And it can help implement the claims mapper and workload identity ideas from CCC or WIMSC. The KBS protocol gives us a simple TE agnostic way for workloads to use a attestation to obtain keys and other resources. And we are not trying to replacing existing verifier services. We want to sit on top of them and make them easier to consume in real-world deployments. And hopefully, we can work together to make the KBS protocol a standard. And we think we can first reduce duplication for everyone. The second, increase interoperability across clouds and TEs. And third, create a solid shared foundation for confidential workloads. And last one, so there are any questions? And I'm very happy to hear about your questions. Thanks, folks.
Thank you, Ding.
Thanks.
Renee?
A great presentation. Thanks, Ding. Two questions. You mentioned support for third-party attestation services like ITA. Of course, there's MAA from Microsoft, GCA from Google, and others. How easy it is to support those other third-party attestation services?
Yeah, we have a common interface definition in the KBS repository. It overall it looks like receives the T evidence and the evidence type and returns JWT token. That's the interface required to do. So if you want to integrate some more third-party attesting services, you just need to implement a simple client that has those abilities.
Got it. And then as far as consuming reference values or making those available, is there now kind of easy standard or way to do that for, say, cloud service providers?
Sorry, my English hearing is not good. So can you?
So Renee, were you asking for the remote value
Yeah.
value providers?
Yeah. How easy it is to make reference values available in this model to this RVPS, or is it like a separate plugin as NRAS is shown here in Verizon?
Yeah, look, I can take this one, I guess. So the RVPS is quite modular. All of Trustee is quite modular, which actually goes to your last question as well. And depending on exactly what your requirements are, there's different places to plug in. But the RVPS has an extractor interface where you can implement different code that can like read from some kind of like reference value manifest and then put it into the RVPS language, and then that will very smoothly go into the policies that the attestation service needs. Currently, we don't have as many extractor modules as I would like, so we should be adding some more. But generally speaking, if you have some format of reference values, it's pretty easy to get those into Trustee. And we also have thought a fair amount about like the different roles here. So if you have one part of your enterprise that's going to be providing the reference values, and then someone else is going to be operating Trustee or something like that, how do you reconcile this? And there's also some thinking that's been going on about how do you then reflect those reference values in the attestation report as well, because obviously what the reference values are may determine, the validity of the guest. So it's important to sort of reflect that. But do you want to put all of that information into the attestation token? Well, maybe not. So anyway, there's some thinking about that too. And there's some evolution that still needs to happen with the RVPS. But yeah, I think the short answer to your question is yes, or possibly no. I forget exactly, but
I think, for example, we have co-RIMs going in right now from some providers. So I think that's an example of something that's fairly standardized.
Great.
Were there
Thank you.
things that you were what kind of reference values were you thinking of, Renee?
Yeah, I mean, this whole model hinges obviously on providing and having up-to-date reference values, right? And obviously that's a pretty complex flow for especially cloud service providers with staying up to date and security fixes and things like that. So just complex workflow that I don't think anyone has fully figured out.
Great. Hank?
Yeah, as an additional comment, and I think my camera is off. So as an additional comment, yeah, CoRIM, you already said that then, I think is a suitable candidate. There is an old school one defined by TCG, and currently in IETF a more versatile next version is hopefully finalized, I want to say. Yeah, and as with the, I want to say, regulation SBOM issue, quorums would have to be created alongside the software supply chain somehow, at least from authority to authority, then handed over. And yeah, so this is basically quorum is intended to take into account multiple requirements that keep the verifier load and policy complexity low. And yeah, so therefore, there's no real great alternative out there. But certainly you could fall back to yet another EAT usage, the entity attestation token. But then again, you would have to define the whole semantics yet again. So I assume without some redundancy today, it's mostly CoREM.
Yeah, I should also clarify that today we don't have a CoREM extractor. That's to do. We want to add that. We have a TCG RIM IM extractor that's not fully like spec compliant, but it works. In practice, a lot of people, we also just have a way you can just tell, hey, here's the reference values. And we have one other I'm forgetting or whatever. So, and there are a lot of subtleties here in terms of like, do you want a pull model? Do you want a push model? How do you handle caching? Things like this. There's definitely plenty of work to do here. But the RVPS we have a pretty good start on this, I think.
Yeah, so there's the HIRS endeavor from the US government. And please don't ask me what that acronym means right now. I know that's a repository name. And so that uses the TCG RIM specification, but that also involves, there's a component RIM now, and it's all based on the SWID or co-SWID specifications. So it is a little bit tailored towards the TPM world. So if you want to have more of a broad stroke for reference values, for example, with nested layering that is in support of DICE, which is also TCG